Okay, so the last lesson we were looking at all the different key features of quadratic functions, what they look like. They look like parabolas, and we were even graphing them by evaluating out a table. So I was giving you the equation, and you just kind of substituted values in from the table, and then just plotted points to graph. Well, in this lesson, we're going to learn how to graph these and find their key features without having to make some big old table. Okay, so we're going to using this is in standard form, written like this, standard form of quadratic functions. I'm going to show you how to get the key features without having to make some big old table. We're going to get all these key features without having to make a big table, plug and evaluate things in. There's different methods and formulas that allow you to get all this stuff. So to get the y-intercept, and we've been talking about this, most of the year, the y-intercept is when x is 0. So to get the y-intercept, just plug in 0 for x. That's all you got to do. To get the x-intercept, you plug in 0 for y. And then you're going to have to solve it using like factoring quadratic formula, or if you're feeling, risky, you can use completing the square, which is kind of tough. The axis of symmetry is an interesting one. It actually has a formula, this formula here, and that's something you'll have to memorize, negative b over 2a. And to get the vertex off of that, you're going to plug in the axis of symmetry. So if I just overloaded your mind right there by spewing off all those different key features, we're going to take it slow one at a time here, and hopefully it'll make more sense. So number one says graph the following quadratic function by finding the key features. So the y-intercept, remember, to find the y-intercept, all you got to do is plug in 0 for x. So 0 squared minus 2 times 0 minus 24. And 0 squared is just 0. 2 times 0 is 0. 0 minus 0 is 0. Minus 24, it's negative 24. So the y-intercept is going to be at 0, negative 24. And, with these standard form equations, once you plug in 0, like watch my pen here, that's just going to cancel out. It's always going to be this, right? Just think of it a lot. Like the y-intercept is always going to be that last number when we're dealing with standard form, because once you plug in 0, those first two terms turn to 0. So it's going to be that last term there. So negative 24 is the y-intercept. So why don't I go ahead and plot that right now? The y-intercept is negative 24. So I'm going to put a dot here. That's my y-intercept. Okay. Next, let's just find the x-intercept. So to get the x-intercept, you plug in 0 for y, or f of x. So I'm going to say 0 equals x squared minus 2x minus 24. And then to solve this, we have numerous methods. We have it has a b term, so we're going to have to either use factoring or quadratic formula. You could try completing the square. I'm going to try to stay away from that, though, because it can get kind of confusing. So I'm going to use either factoring or quadratic formula. And this one, the leading coefficient's 1. I think factoring is going to be not too hard on this. So it's got to multiply to negative 24, add to negative 2. I think that could be negative 6 and positive 4. And remember, you can distribute it back out to see if you factored it correctly. So now using the zero product property, I can kind of break these up. X minus 6 equals 0, and x plus 4 equals 0. Add 6. X equals 6. Subtract 4. X equals negative 4. So those are my two x-intercepts, or root solution zeros. Those are all synonyms there. So I'm going to plot that. So here at 6 is one of them. And then at negative 4 is another one of them. So I've got some key features. I know it's, I can know the y-intercept. I know the x-intercepts. So I know it's going to be some sort of, if you look at my finger, it's going to be some sort of U like this. But now all I'm waiting for is where that axis of symmetry is and where that vertex point is going to be. Now, if you're thinking ahead like I am, I kind of already know where the axis of symmetry is going to be. It's going to be in the middle of these roots, right? You know, if you had a root at negative, it should be at 1 here. Now I'm going to erase that line because I don't want to give it away, even though I kind of did. I want to show you how you find it with the formula. So, whoops. The axis of symmetry formula is up here highlighted in yellow, negative b divided by 2a. So x equals negative b. So b is negative 2, so it's going to be negative 2 divided by 2 times a. A is 1. So that's going to be 2. 2 times 1 is 2. And 2 divided by 2 is 1. So I know the axis of symmetry is going to be at 1, just like I speculated. So axis of symmetry going to be right here. But now the question is, where's the vertex? Where on the axis of symmetry is the vertex? It obviously wouldn't make sense to be like up here, right? That makes no sense. It's going to be down below somewhere, probably lower than the y-intercept, right? If we're going to try to make that parabola. So let's, so in order to get the location of the vertex, we have to plug in the axis of symmetry. Reason being is because the vertex is on the axis of symmetry. The x value of the vertex is the axis of symmetry. So I'm going to substitute 1 in for x because that was what the axis of symmetry was. 1 squared is 1. Negative 2 times 1 is negative 2. 1 minus 2 minus 24. 1 minus 2 is negative 1. Minus 24 is negative 25. So my vertex is located at 1 comma negative 25. So about here. Now what I like to do sometimes is draw a little symmetry point from a y-intercept. So there should be a point here as well because it's symmetrical across the axis symmetry. Okay. And there it is, a very pretty symmetrical parabola by finding the key features. So always refer back to these kind of notes up here if you don't remember how to find the key features. All right, I'm going to show you one more. Okay. So here we have this function. Let's get the y-intercept first. Now the y-intercept, you can just tell by looking at it. It's 18. It's always going to be this last number when it's in standard form. Reason being, though, just so that you understand, if you're trying to find the y-intercept, you have to plug in 0 for x. And if you plug in 0 for x, just let me show it. Zero squared, 0. Negative 2 times 0 is 0. 16 times 0 is 0. 0 plus 0 plus the 18 is 18. So it's always going to wind up being that last number when it's in standard form. So the y-intercept, I'm going to write as a coordinate, is located at 0, 18. So we'll put it about here, I guess. That's good. Let's get the x-intercepts next. So that's to plug in 0 for y, or in this case, g of x. So 0 equals negative 2x squared plus 16x plus 18. So on this one, you could either factor it, use the quadratic formula. It's really up to you. Personally, I would factor it, but I'm trying to debate in my head if I should use the quadratic formula just to review it with you. I'll use the quadratic formula. Why not? So x equals negative b plus or minus square root of b squared minus 4ac over 2a. So here we go. Negative b, so it would be negative 16 plus or minus the square root of b squared. So 16 squared minus 4a is negative 2, c is 18. over 2a, so 2 times negative 2. Negative 16 we'll have here. 16 squared, I imagine it's pretty large. 16 squared is 256. I just typed that in. Negative 4 times negative 2 is positive 8. 8 times 18 is 144, so plus 144. 2 times negative 2 is negative 4. Let's keep it moving. 256 plus 144 is 400. Now, you may not know this, but 400 is a perfect square. The square root of 400, again, just type it in, is 20. So I have negative 16 plus or minus 20 divided by negative 4. So at this point, I can split it up. I'll use red here. So I'm going to have negative 16 plus 20 divided by negative 4. And negative 16 minus 20 divided by negative 4. That would be negative 16 plus 20 is positive 4. Positive 4 divided by negative 4 is negative 1. Apologize if I'm going super fast. Just want to get through this. Negative 16 minus 20 is negative 36, right? Yeah, okay, divided by negative 4 would be 9. Okay, so I have roots at negative 1 and 9. Okay, so this is what we got so far. Makes sense, I would say. So my axis of symmetry, I'm still missing my axis of symmetry and my vertex, right? Missing those two things. So I have a feeling this, if you look at my hand, I have a feeling this is going to be like going like this. It's going to be like a upside down U. And that makes sense. I know we didn't talk too much about this, but this leading coefficient is a negative. So that means that it should be an upside down U. So I think we're on the right track here. Now we still need to get that axis of symmetry. Now the axis of symmetry, I can eyeball it where it's going to be at. I think it's going to be at 4 because that looks like it's in the middle of those two red dots, the two roots. I think it's going to be at 4, but let's make sure we know how to use the formula. So axis symmetry, the formula is negative b divided by 2a. So I'm going to do negative b, so negative 16 divided by 2 times a, which would be negative 16 divided by negative 4, which is 4, just like I suspected. So the axis of symmetry is at 4. So I'm going to draw a little dashed line to signify that. Now the question is, where on the axis of symmetry is the vertex? Now I think it's pretty clear to say that it's going to be up here somewhere, right? I just don't know where on that line. It's going to be on that line of x equals 4. We just got to figure out where on that line is. And the only way to do that is to plug in 4. Plug in the axis of symmetry to the equation. So I'm going to go negative 2 times 4 squared plus 16 times 4 plus 18. 4 squared, 16, so negative 2 times 16 I'll have here. 16 times 4, what's that, 64, I think? Negative 2 times 16 is negative 32. Again, sorry if I'm going really fast. But you always have the liberty of pausing it if you need to. Negative 32 plus 64 is positive 32 plus 18 is 50. So this is 50, meaning the vertex is at 4, 50. So here. So nice. We got all the key features. Now, kind of like the previous problem I was saying, just to make sure the line looks pretty, I usually like to draw a symmetrical dot for the y-intercept. So like this y-intercept's like 4 away. So I think like here, it's a nice symmetrical dot. I'm just putting it there just so that I make sure my u looks pretty. Okay, so I shouldn't say u. I should use the correct terminology. The parabola looks pretty. It's a parabola. Try to make it curve as much as possible. Kind of looks like a V, but it's supposed to look like a U. All right, so that's how you graph equations written in standard form. So you try the rest.